I'm going to talk about coronal experiments and observations. Here is a wide-angle view showing how small the corona actually looks in the sky. Some of you heard me talk earlier about how to watch an eclipse, and now I'm going to the close-ups. I'll start with some observations we made in 2012 at the total eclipse of the sun in Australia. We were in Mialo, and for reasons of weather, sent some of our equipment and people to Mount Carbine. Here is a helicopter view showing the umbra with the corona in the middle that I saw, and we have a set of observations that we made with clear skies. We also have spectra. You can see very prominently at the top the coronal green line from iron-14. That's 13 times ionized iron. It takes 1 million plus degrees, about 1.5 million, to drive half the electrons off. There are predictions made of the coronal configuration of the magnetic field using MHD by Zoran Mikic and John Linker, and we compare that to our observations that you see on the right, and you see that in general things match, but not specifically. We did see between our observations and 36 minutes later a coronal mass ejection that had gone out over 500,000 kilometers, so literally over 1 million kilometers an hour. The next eclipse was in Africa. In Totality passed through Gabon, the first land that you see there as the path of Totality reached Africa. And again, we had a variety of observations. Here is a composite of several dozen individual images, and you can see 2 coronal mass ejections, one on the left, one on the right. You can see an erupting prominence in the red there. You can see the chromosphere on the edge, and we link our observations in this donut of black that you see there with some of our inner corona observations with spacecraft observations in the ultraviolet in the center there, pasted in over the size of the moon, and the coronagraph observations from space in the outside. And you see we have this whole region to study uniquely. As Lika was explaining before. The next eclipse went across Svalbard in the Arctic in 2015. You can see the coronal shape is fairly symmetric around, but with a deficit at the lower left. The previous eclipse had been symmetric all around, so we're seeing a variation in the shape of the corona over the Sunspot Cycle. You can see that the sun was very low at this time, and you can see that and speeded up 10 times the corona going by there, the eclipse, the umbra going by. So we are following the shape and the temperature of the corona over the solar activity cycle. Here again, you see an overall round corona, but we expect things to have many fewer streamers at high latitudes, given that we are approaching the minimum of the sunspot cycle. The most recent total solar eclipse was visible from Indonesia last March. We observed it through a hole in the clouds, so we didn't do so well in the outer corona, but we could see the inner and middle corona. You can see on the top here all the different phases. The most recent solar eclipse of any kind went across South America and into Africa on February 26th. This was an annular eclipse when the moon is a little further away than average, and therefore a rim of sunlight, an annulus, appears, and here's just a series of images. And as you heard before, and here too, we're using these annular eclipses especially for testing, and you can see the Baily's beads, and you can practice your equipment and your cameras to make sure that they're all functioning. The last solar minimum eclipse, here's going back to 9 years ago, that we observed from Russia, from Siberia. You can see now there weren't so many streamers at high latitude, so we see these polar plumes. And we can measure the motions in the polar plumes by looking at various places around. I don't think you have to have continuous coverage. Every few minutes is good enough. Here you see the sunspot cycle really declining. This is as of this month, and the yellow is the daily images. So you can see on many days of this year and last year there were 0 sunspots on the sun. So we are hoping for some active regions to study, and possibly some eruptions. There was a big eruption a few days ago. We also have been granted time on the very large array, the big radio telescope array in New Mexico. There are some ionospheric observations being made in the middle of our coronal observations. The picture that you just saw was from observations we made with my students among the antennas while we were using the antennas to study the radio sun at that time. The radio emission comes from active regions. So we're trying to do everything we could think of. Thank you.
Thanks, Jeff.